Welcome you all. My name is B. Vinodhini. I welcome you all for my lecture series of automata theory and compiler design. In last video, we have seen that what is a finite automata and the difference between the finite automata and the NFA, difference between that NFA and DFA, and how we can convert that NFA to the DFA using that procedures. In today's video, we are going to see about that push-down automata. Already we know that what is the types of automata. In types of automata, we have four types. One is a push-down automata, and that finite state automata, linear bounded automata, and Turing machine. Based upon that grammar classification and the memory storage, this automata is classified as four types. For each automata we have a certain grammar, and it accepts some languages, and it uses some applications. In today's video we are going to see about that what is a push-down automata. So the push-down automata, it is that way to implement the context-free grammar in a similar way to design a finite state automata for the regular expressions. So I recap that Chomsky hierarchy, that push-down automata, and the based upon the Chomsky hierarchy, the types of grammar is type 0, 1, 2, and 3. So the language accepted by the type 0 is a recursively enumerable language. The automata, it is a Turing machine. The type 1 is a context sensitive language. The automata is a linear bounded automata. And type 2 grammar, it is a context free language, and the grammar is a context free grammar. So the automata accept that type 2 is a push-down automata, and type 3 is a regular language, and the automata accepted in the finite state automata. So the finite state automata, it not applicable for all the domains. It should have the limited memory because there is a necessity of some languages which they will have to memorize or recognize that memorize the previous set of histories. For example, we have a language like a power n followed by the b power n. That means how many number of a will be that should be equal to the number of b's. That is that language. So that type of language we cannot do in the finite state automata, because in the finite state automata we don't have a stack memory or the temporary memory. We have a limited memory. So from the state 0, it reads the input symbol and goes to the next state. That is a finite state automata. But in the push-down automata, it is a more powerful than the finite state automata. So it has a more memory, because it is a combination of the finite state automata plus stack. Already you know that what is a stack. Stack is a linear data structures, and follow the principle of last in first out. That means the last inserted element should be removed first. That is a stack. So the every operations like insertion and deletions, it call it as a push and pop. For inserting or push the element to the stack, we are going to increment the top pointer, and for the deleting or the pop operation, we are going to decrement the top pointer. This is the basic introduction about the stack. Already you know that what is a stack. So the push-down automata, it is a combination of the finite state automata and stack. So what is an application means, we are using in the calculator and Java and C program, we are going to use that push-down automata. So now we will see that components of the push-down automata. In that push-down automata, we have an input tape, and we have a finite control unit. On addition that we should have a stack. So this is that input tape and final control unit is a finite state machine. Next, followed by the stack. For stack is used to for that storing the element in the memory. So finally, based upon the things, we have to find out whether the given string is accepted or rejected. So the components of the push-down automatas are input tape, finite control unit, and stack. Now in this slide we will see about what is the formal definition of the push tone automata. So what is a finite automata definition? It should contain the 5 tuples. Like that finite state automata, we are adding the stack also. For the stack information also we should need to store. So based upon that, the push tone automata contains the 7 tuples. The 7 tuples are q, sigma, then gamma, that is an uppercase gamma, and then transition of delta, then q naught, z naught, and f. Now we will see one by one. What is a q? Q is a finite set of states, and sigma, it is a finite set of input symbols. Next is a tau. Tau means it's a uppercase gamma, so it is a finite stack alphabet. Next is the transitions, that is a transition function. So the transition function also differ from the finite state automata and push tone automata. Next is a Q naught. Q naught is a starting state, and Z naught is a start stack symbol, and F is a set of final or accepting state. So this is a 7 tuples should contain the push tone automata. This is a formal definition of the push tone automata. So we have a combination of final state automata and stack. Now we will see I said that the only it is different from that transition. So the transition takes an argument a triple. For example, we have a state, then input the input symbol either a or epsilon, and the stack symbol, that is a number of how many, it is a member of a gamma. So this is the three things we have, and it takes that argument for the transition. For example, it is taken argument is a 3 means the output of that transition is a finite set of pairs like p comma gamma, where p is a new state and gamma is a string of stack symbols that replaces the x at the top of the stack. For example, if gamma is equal to epsilon means the stack is popped. Suppose it is and no changes means that stack is unchanged, so that is the next means. Suppose you have an y comma y z means then x is replaced by z and y is pushed onto the stack. So the x is replaced and y is how the stack representation of y is that y is in the top, z is in the z is in the top and y is in the bottom. So the z is x is replaced, y z means y is in the top, so the z is replaced with that x and y is pushed onto the stack. This is that transition function differ from the finite state automata and push tone automata. Now in this lectures we are going to see about what we have seen means what is a push tone automata, why we need the push tone automata, and what is the formal definition and how the transition should be done in the push tone automata. In next video, we will see that example of a push tone automata and how the input string is accepted in the push tone automata. Thank you.